Hello, everybody. Can you hear me in the back? Awesome. All right, tonight, prepare yourself for mysteries that have been behind closed doors, closed lab doors for too long. Because today, for the next 15 or so minutes, I am going to peel back that curtain and reveal to you the dastardly science that's been going on in labs around the world of scientists playing God, building living robots. Now, why should you listen to me? Well, I am ashamed to admit I was one of these scientists. I just finished my PhD in mechanical engineering, and the title of my thesis was It's Alive, a toolkit for creating biological robots. And during this time, I thought a lot about the upcoming inevitable robot apocalypse. And if that's not enough, I just wanted to let you know that dogs really love me. And hopefully that ingratiates me to you. So here's some footage that I had sequestered out of a top secret lab. This is found footage of a scientist tampering with the very fabric of nature against the will of God and man alike. This was based on the work, of course, of Mary Shelley et al. And this experiment was deemed a success, reanimating the dead. Now, you may say, Saul, I thought this talk was about living robots. What does Frankenstein have to do with that? Well, Frankenstein is a piece of flesh that was once inert, and then with the magic of science was reanimated to do the scientist's bidding. And that ultimately is what scientists are trying to do with these living robots. But when we think about robots, we're not thinking about Frankenstein. No. We're thinking about these charismatic guys. Oh man, look at them! They're dancing! Nothing bad can happen to something, nothing that's dancing like this can hurt you, right? These guys are harmless, they're so charismatic. What could happen, right? What's the worst that could possibly happen? Well, let me move on to Exhibit B. I'll show you what can happen. Again, documentary footage. This is from the documentary Terminator 2 Judgment Day, aired in 1991. And this is what happens if we're not careful with our robots. They will crush our bones. They will steamroll over our society and end life on this planet as we know it. But this does not have to be the future that we live in. Instead, in fact, we don't see robots out in the world like this, thank God. And similarly, for Boston Dynamics robots, unless maybe you work at Carnegie Mellon, you don't see too many of those out in the world either. Instead, what you see mostly are these guys. Maybe a Roomba adorned with a cute, fluffy friend, knocking harmlessly into a chair. Ain't nothing wrong with that, right? This is great. And so tonight, I'm going to sort of peel back the curtain behind what robots can do, especially living robots, and we'll end with if you should be scared. So the roadmap specifically is why do we build robots at all? What's the point? I'm going to talk about what even is a living robot if it's not Frankenstein's monster. What can current living robots do? And I'll point out they do exist. Some arcane living robot magic. How do people build these robots, and how do they interrogate them to make them better? And finally, the ultimate question, should we be fearing these dastardly beings? So to begin, why do we build robots? One way to frame this question is to think about the 4 Ds. And these are all about automation. The first D is we want to automate things that are dull, like moving boxes around a warehouse. We want to automate things that are dirty, maybe like cleaning out a sewer, maybe like desilting a river. We want to automate things that are dangerous, like dealing with bombs, unexploded ordnances, or handling nuclear waste. And finally, we want to deal with things that are inaccessible. These are things like going to Mars, or minimally invasive surgery, where the hands of a human are just too big for the task. So this is great. We've got robots that can do these tasks, but obviously there's more tasks that we want to do. And as always, science never stopped to think if it should, and instead progressed forward to see if it could. And that's what led researchers to build these living robots. Now, what is a living robot? Well, a living robot is when you take some mechanical component, maybe a gear, you add some biological component, maybe muscle, or if you're feeling really fancy, some neural tissue like a brain, and then boom, you got it. You have a living robot. But what does that actually look like, right? What can current living robots actually do? Well,
meanwhile, in a major breakthrough in making robots seem less frightening, a robot got a face of living skin that allows it to smile.
I just want to pause here for a moment. That is really upsetting to hear, I think, for any of us, certainly myself. And I want you to take a moment, and again, here's that headline from the New York Times. I want you to imagine in your mind's eye, what does this look like? What could this possibly be manifested? Well, I fed this exact headline into ChatGPT, and here's what it gave me. It gave me this, which is somewhere between cool and upsetting and unnerving. It's a little unpleasant, but ultimately this is something that maybe you could grow to live with. Unfortunately, the reality of what the scientists made are so disgusting, I thought I needed a warning. Here's what they actually built. I don't really have words to describe how this makes me feel, but none of them are positive. This certainly is against the will of God and man, and I can't really countenance why it was created in the first place. Unfortunately, scientists around the world didn't stop at this monstrosity. They also created an episode of Black Mirror by creating remote-controlled flying beetles, by implanting electrodes by their flight muscles, and then hooking it up to a Wiimote. Yes, that's right, the remote that's used to control your Wii, gaming console. And with the angle of that Wiimote, they can control how that bug flies. That's the video on the bottom right. I just want to let you know this work was funded by the Defense Department, so that should make you feel a lot better about it. Finally, I want to walk you through some more, academic instances of these living robots coming from research labs that are a little bit more staid. So here we see a robot where a strip of muscle is spanning sort of this inchworm mechanism, and by contracting the muscle with electricity, with just wires on either end, they can get it to crawl across a dish. In a similar instance, muscle is patterned on a thin, flexible sheet, and then by being strategic about how it's patterned, it's able to get that sheet to swim, either like a jellyfish in the top video, or like a ray in the bottom video. And then by adding more muscles, we can get these robots to do more interesting things. So in this case, we've got two muscles in what's known as an antagonistic pair, and we can get it to pick things up and then place them down. And this trend of using more muscles to accomplish sort of more functional tasks continues. So if you stitch two of these inchworm robots together, you can now get them to turn by sort of selectively making one move faster than the other. Another instance of sort of more muscles creating more functionality is this assisted, let's call it bipedal walking. Here we have this floaty made of styrofoam that keeps this whole robot up, and basically by sort of manually stimulating one muscle with these little electrodes and going to the other, they can get it sort of very slowly walk across this little dish. And then similarly, fish-inspired swimming was achieved by other researchers, again with muscles that are patterned on it. In this case, they are sort of self-stimulating, which is quite an achievement. But this is all great, but I know that you're wondering, Saul, I'm so interested in biohybrid robots and these living robots. I want to know how to make them myself. It looks like PowerPoint has crashed. That's okay, folks. We're back online. I want to know how to make them myself. Well, I'll tell you how. The way that they're currently... We're good, folks. We got it. Oh, it crashed again. All right, pulling it up one more time. Do not restart in safe mode. Thank you, Windows. Alrighty, folks, thank you for bearing with me. So I know that you're just at the edge of your seats waiting to know how you can use this arcane knowledge to build your own living robots. And so there's some magic involved in doing it. And as we're all nerds here at Nerd Night, I thought we could start off with a little quiz. So first off, how do we think current living robots are made? Do we think that it's A, they are grown in a cauldron with Eye of Newt, trademarked by Sigma, of course? Are they instead 3D bioprinted using these fancy, or 3D printed using fancy bioprinters? Could they be painstakingly pipetted, casted, and tweezed by hand by over-caffeinated graduate students? Or instead, are they raised lovingly by a traditional nuclear family? Can I get hands for A? Okay, not so popular. B, hands for B. Okay, all right. How about hands for C? Quite a few hands went up. And then traditional nuclear family, D, anyone? All right. So the answer is C. They are painstakingly pipetted, casted, and manipulated by tweezers by underpaid graduate students. And this should give you some solace, because if you're thinking about an upcoming living robot apocalypse, I can assure you from personal experience, it's very difficult to make even one, let alone the hundreds of thousands that would be needed to overrun our society. So we're all quite safe. But they do use a very cutting-edge technique in biofabrication, which I alluded to before, and that, of course, is graduate student with tweezers. So it's very important that the graduate students spend many hours in the lab and that they learn these really arcane techniques so that they can very gently tweeze these extremely delicate structures and move them from one dish to another so that they can grow more fruitfully. This takes a lot of time and years of training, and so fortunately, it is still quite nascent in the research phase. So beyond making them, one big question that challenges or that excites people in this field is how can we sort of look at the structures that we're growing under a microscope and identify sort of key components and how they're maturing? And that gets us to the arcane magic of immunostaining. This technique sometimes involves all of these animals at once, though normally just a few of them. A person, a mouse, a rabbit, a goat, and a chicken. And I feel like the only time we get all of these creatures involved is when we're doing some sort of witchcraft or wizardry. And so I thought it was useful to sort of frame it in terms of that. One way that this works, this immunostaining technique, is first, let's say you've got some muscle, and there's a particular part of the muscle that you want highlighted in your microscope image. That's often called an antigen, but that word is too jargony. So we're going to call her Auntie Jen. Auntie Jen is a spunky redhead. She looks like Miss Frizzle, and she's here to help you with your science. We're going to follow Auntie Jen into, of all places, a goat. Why a goat? Well, it turns out the goat will have an immune response to antigen. The goat does not like when you put muscle inside of it from another being. And so it will create what's called an antibody that will attach to antigen. We want that antibody because that means that we can now tag that structure, that antigen. But we don't want to just tag it, we also want to be able to see it. So what we do is we isolate the blood of the goat. This is all 100% real. And then we purify it, and then we add a fancy glowing orb to the antibody. And that allows us, whenever we put that antibody into a sample, and we do some fancy science to it, we can now see that part of the sample grow, right? So we're going to take that now tagged antibody, and we can put it into our sample, and what do we see? We actually see what I would argue are some of the most beautiful images that science has to offer. We see gorgeous structures like this. I don't know how well it's coming out for you, but in green, we can see the nuclei that are fused between many muscle cells that form these sort of larger hierarchical muscle structures. And then in red, we see the structure of the muscle itself. And so if we're trying to interrogate how the muscle is growing, this is extremely useful because sometimes muscles will grow in ways that we don't want. and this can help us troubleshoot those things. But beyond growing muscle and interrogating those structures, it's also useful for understanding embryonic development. So if we're trying to look at how the skeleton is sort of developing inside of this really cute embryonic sea turtle, the red is illustrating where the bones are starting to grow. So this technique is actually used in many fields in biology. Similarly, we can understand neuroscience better. Here, serotonin is tagged in a neuron, shown in red. And also, we can understand how our guts operate. Here is a cross-section of an intestine of a mouse with different structures tagged. And all of these images, I think, are extraordinarily beautiful and quite inspiring, that we can sort of illuminate, quite literally, the basic building blocks of life to understand it better and build a better world. So the key takeaways are first that living robots are too immature to hurt you. They are baby, you're safe. The second takeaway is that science is basically alchemy, sometimes. How is goat blood involved in my research? Honestly, how remarkable. And then the last takeaway is that science can be incredibly beautiful. And so even when we're doing these sort of crazy science experiments, I think it's always important to reflect back and see sort of the beauty in the work that we're doing. And so the final question, of course, is should we fear the living robots? Can I get hands for yes, we should? Okay. How about hands for no, we shouldn't? We're okay. All righty. Well, just as a reminder, this is how we started in the field around 200 years ago, reanimating the dead, and then this is sort of how it's going. This is where we are right now. So with that, I thank you so much for your time.